So hi guys, we are back again, and this time we will be discussing a rule for evaluation of limits, that is L'Hopital rule. So let's say we have to evaluate limit at some point x approaches to a fx over gx, and this a can be any real number as well as positive infinity or negative infinity. Right, so these are the values of a which a can belong to. And this limit x approaches to a fx exists, as well as limit x approaches to a gx also exists. But the result of this overall limit comes as 0 over 0 or positive infinity or negative infinity over positive or negative infinity. So if our answer when we evaluate the limits comes like this, 0 by 0 or plus minus infinity over plus minus infinity, then in that case we will be solving our limit, evaluating our limit, I'll rather say, by the L'Hopital rule. Okay, so let us first define what exactly is L'Hopital rule. So this limit, limit x approaches to a fx over gx is our consideration. So we can, under L'Hopital rule, we can write this as limit x approaches to a fx over gx as limit x approaches to a f prime x over g prime x, or you can say f dash x over g dash x. And what is f dash x and g dash x? F dash x and g dash x are derivatives of fx and gx respectively. Now what is derivative? That I will be making you clear with some upcoming videos, but for now you just remember that f dash x or f prime x is derivative of f of x, and similarly g dash x or g prime x is derivative of g of x. Now how we can define derivative? Derivative is like rate of change of that function with respect to the input parameter. That is, f dash x or f prime x is the rate of change of fx with respect to x. You just remember this definition for now. Okay, so the rule is limit x approaches to a f of x over g of x if it comes to either of 0 by 0 or plus minus infinity over plus minus infinity, then we can evaluate it as limit x approaches to a f dash x over g dash x. That is, we differentiate the numerator function and as well as the denominator function. Okay, and if again it comes as 0 by 0, this thing, if it again comes as 0 by 0, then we again differentiate that. So let's stick as for now to single differentiation, right? So this is the rule, this is the L'Hopital rule which I just introduced to you. Okay, so let's look at an example to make it a little bit more clear. Let's say this is, we have a function limit x approaches to 2 x cube minus 4x square plus 4x over x square minus 4. So this is our question, and we have to evaluate limit at x approaches to 2, right? So now let's first put the limits in this numerator function as well as the denominator function. So this will be, we just, because both are just polynomial functions, so we can just directly put the limits, and we observe that this is 8 minus, this is 4 times 4, that is 16, so 8 minus 16 plus this is 8, so 8 minus 16 plus 8 is nothing but 0. Similarly, this is 2 squared, that is 4 minus 4 over 0. So we see that it is coming as 0 by 0. Okay, so let's first go by a basic factorization thing, how if we can factorize both of these numerator and denominator, right? So let's go by the factorization thing first. We see that x, if we put this in this polynomial x equal to 2, then this polynomial is resulting into 0. That means x equal to 2 is a factor of this polynomial. So we can write it as x minus 2. X equal to 2 is a root of this polynomial, right? So x minus 2 will be a factor of this polynomial. So that means this is a factor, and if we divide this x minus 2 with this whole polynomial, we'll be having a question that will be equal to x square minus 2x. So this polynomial, we can factorize it as this x minus 2 into x square minus 2x. And this x square minus 4, this can be written as x minus 2 into x plus 2 by the identity a square minus b square, right? So this will be limit x approaches to 2, and also this thing x square minus 2x, this can be split like x, this will be x minus 2, and this will be x if we take out the factor x out of this, and this will be x minus 2 once again, right? So this will be x minus 2 and x plus 2. So now if you look that this in this full evaluation of limit, x is approaching to 2, it is not equal to 2, right? So we can cancel this factor with this factor. Since x is not equal to 2, if it had been 2, then it will be like 0 by 0 form, right? So we can't put x equal to 2 here. But since x is approaching to 2, right? So we can cancel out this factor x minus 2 in the numerator as well as the denominator. So this whole thing will come as limit x approaches to 2 x into x minus 2 over x plus 2. So if we put limits now, so it will come as 0 into, this will 2 into 0 over 4. So this will be 0. So the answer is 0. But now this we have done with the help of factorization. Now let's introduce the L'Hopital rule here. So what is L'Hopital rule? L'Hopital rule is, if you can recapitulate, it is like if the function, like this in this example, if the limit, if we just put the value of x, like if we evaluate the limit at the point and the evaluation is coming at 0 by 0, the answer is coming at 0 by 0, then that L'Hopital rule can be applicable. So here we can apply the L'Hopital rule. So what is the L'Hopital rule? It is limit, the function was limit x approaches to, let's first write the L'Hopital rule once again. So it is like limit x approaches to a fx over gx. If it is a form 0 by 0, 0, so it is a case in our example, so then we can simply write it as limit x approaches to a f prime x or f dash x over g dash x, right? So let's take now our example. The example was limit x approaches to 2 x cube minus 4x square plus 4x over x square minus 4. So now I'll be differentiating the numerator as well as the denominator. So this we can write x approaches to 2. So differentiation of x की power n is n into x raised to the power n minus 1. So this result you have to remember as for now, and we will be taking this further when we will be discussing about derivatives, right? So as for now, you just remember this simple formula that derivative of x to the power n is nothing but n times x to the power n minus 1. So by this definition, by this rule basically, we'll be differentiating this numerator as well as the denominator, right? So x cube differentiation will be 3 times x 3 minus 1, that is 2, minus 4. Since this is a constant, we can take it out, and x square definition of an derivative of x square will be 2 into x to the power 2 minus 1, that is 1, plus 4 times x, derivative of x will be 1 into x to the power 1 minus 1, that will be x to the power 0, so that will be 1. Okay, so similarly in the denominator it will be 2x, and differentiation of a constant with respect to x or any other variable will be 0. So this thing also you have to remember. So the differentiation of this constant, that is 4 here, will be 0. So this is the differentiation of the numerator as well as the denominator, right? So I'll write it more clearly now. So this will be 3x square minus 8x plus 4 over 2x. So now let's put our limit again. So this will be, this numerator thing will be 3 into 4 minus 8 into 2 plus 4 over 4. 2 times 2 is 4, right? So this is 12 minus 16 plus 4 over 4. So this is 0 over 4 and it is coming as 0. So 0 is a valid result and 0 can be the answer. So this limit, the evaluation of this limit is coming as 0. So did you observe the difference between this thing and this thing? So this was the factorization technique. So dividing this polynomial, like breaking this polynomial into form of factors, will take a lot of time, right? So it will take some hard work in order to calculate the limit according to this technique. But contrary to that, if we evaluate the limit by this method, right, so it can be really faster. If you just know the differentiation of the numerator function and the denominator function, you can easily evaluate the limits, right? So this is a little shorthand technique of evaluation of limits. So guys, let's look at another example on this L'Hopital rule. So our question is, limit x approaches to a, x to the power n minus a to the power n over x minus a. Now let's put the limit x approaches to a in this function. So that will be a to the power n minus a to the power n, that will be 0, over a minus a, that again will be 0. So this is of the form 0 by 0. Then we can easily apply L'Hopital rule here, since it is applicable here, right? So let's apply that rule. So what the rule was? It was limit, let's say at x approaches to a only, fx over gx. If both of these limits exist, and the limit x approaches to a fx and limit x approaches to a gx, both this limit exists, and our evaluation is of the form this fx over gx, and the evaluation is coming like 0 by 0 when we put the limits, then we can apply this L'Hopital, and this will be limit x approaches to a fx by gx equals x limit x approaches to a f dash x over g dash x. This is the derivative. F dash x is nothing but derivative of the function fx, and g dash x is nothing but derivative of gx, right? So let's differentiate both of these denominators and numerators, right? So this will be f dash x will be, so x to the power n, as I discussed in the previous part, differentiation of x to the power n is n times x to the power n minus 1, and a is a constant, so constant to the power anything will be a constant, right? So the differentiation of constant was 0, so this is 0 over x. Differentiation of x is 1 into x to the power 1 minus 1, so that will be 1 minus 0, since a is a constant, right? So this comes as limit x approaches to a n times x to the power n minus 1. Now we can now easily substitute x equal to a in this thing, right? So that will be n times a to the power n minus 1. So the limit comes as n into a to the power n minus 1, right? So this is very easy way of evaluation of this limit. Now, contrary to this, if you have applied, like if you have factorized this thing, like let's say this is this polynomial x to the power n minus a to the power n, this also has a factor x is equal to a. So you guys must have divided this thing by x minus a, which is here in the denominator. So it will be really very tedious to calculate the factors of this polynomial. So like it will take a lot of time, and eventually it will be like very time consuming for the final limit to be calculated, right? So this is very fast, right? This is really, really very fast. The limit, I guess, like it took around 1 or 2 minutes, maximum one or 2 minutes to come to this answer by L'Hopital rule. So this is very quick way of evaluation of limits, which you can either use in order to evaluate your answer, or if you want to verify your answer, you can easily take a help of this rule. So guys, this was it for the L'Hopital rule, and do join me for the next set of videos when we cover the remaining concepts of limits. Thank you. Bye bye.